Thank you all for joining the session. Before we actually start, I will shortly introduce myself. I'm Cees. I'm a software engineer at OpenValue. As OpenValue, we help other companies with their software challenges. We're working in the teams at the company. My focus is observability, reliability, and also troubleshooting. I'm using Grafana already for quite a while, and I started sharing my experience about that on the blog, and also now in this talk. So I will show you what I learned in this situation. Are you ready for an incident investigation? I'll take you on a journey which I had on finding the actual problems in one of the systems we had. I will give you a bit of the background. I will show you the tools I used, and we will do a step-by-step investigation on this. About the background. We have a Java messaging server, JMS server, which is a server where you have message queues. So a producer is connecting to it with a persistent connection to it to be able to push messages on the queues. And also consumer applications also creating a connection to it, consuming the message and probably replying on it if you have a request reply set up, or a fire or forget, then it's just handled and no answer sent back. During one of the incidents, it started with network patching. According to the network team, the patching went flawless. Only 2 seconds downtime, and then all network traffic was fine again. But still, a lot of applications were not able to connect again to the JMS server. So we're wondering, okay, why is that? And also, in the post-mortem session, one of the things you often hear is, yeah, it's the network. The network, we have TCP, it's designed to be able to handle this. But is it then the root cause of your problems? Or is it probably the trigger of your problems, and is your application not able to handle it? And let's see what we can find there. This is my Swiss Army knife, as I call it. I use a lot of the Grafana tools also locally to do the analysis. Here you still see Promtail and OpenTelemetry collector. Yesterday we heard Alloy is there, so in the next version I will update that. But this is what I used, and what I used in this case, I asked the team of the JMS server, can you provide me the log files? And I used Promtail to load that into Loki. And one of the features I use as well is the replace feature, also to hash some values. So you can't see the actual values, but you can see the hashes. So you can see information about the users and the host names and IP addresses, but they are hashed, so you can't see the actual details. So let's have a look at it. A question for you, Explore feature. Who of you is using the Explore feature a lot? Okay, nice. I use it a lot because the dashboards, most of the times there are the known things to look for. But also in these type of cases, there is also a lot of unknown things. And the Explore feature really helps to find these problems. And now we're also with announcements yesterday also about the Metrics Explorer and also the Log Explorer that will really help also in my daily job to find whatever issues are there. I loaded the JMS logs, so you will see a number of LogQL queries, but also that will also with the new features will become less if you can use the Explore log feature. I selected here the JMS logs for a certain server, and what you can see, the network patching was done during the night, and you can see here the spikes of the number of messages. So that indicates that there is a problem at that moment. Zoom into the situation. What you can see here is here at the back of the line you see disconnect, 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 disconnect. So the JMS server detected that also all the connections were dropped. Then we will go down and then go down and you have to scroll a bit. And then you will see, so new connections are coming in. And what you, so I will take another one. Oh, no, that's a bit too early. So what you can see here, for example, at this line, you see here, okay, we do have a connection. And what you, if you, no, we take this one. So what you can also see here is there is an offset. And the offset is calculated by the server. The offset is between the moment the client tried to create a connection and the server actually confirmed the connection. And if you have between these two moments an offset of, this is milliseconds, 2.5 seconds, to create a connection, that's quite long. So either there's network latency or other problems, or that was also in the documentation, probably an issue with a lot of connections coming in. So let's see if we can find more information about that of that offset. So if you zoom into that, then you see this is also with the Logcli query highlighting the offsets, and you see the offset is growing over time. So it's getting bigger and bigger. So that gives an indication of something which is going wrong. And then I thought, okay, but what if we could visualize this? Because that helps in the investigation. So if you then have a look at, so also again with the Logcli query, you can take the query, you can take out the offset. So with the regular expression, take out the time for the offset, and then with an average over time, you can see what the average values is of that offset over time. And you see it's, especially at the first part, it's growing fast. And you see here 30,000, 40,000. So it has to wait 30 seconds before the connection was created. That's quite long. But if you also have a look at the times below, you see 30 seconds, then it looks like that everything started to connect in this period and just piling up. So what is there? Oh, the one thing I forget to show. No. What is here as well is, as soon as a connection is established, here is also, you see here is also a message authenticated via auth module. So there is also the authentication happening for these applications. So in this setup, you have the producer and consumer connecting to the JMS server, but to see if an application is allowed to connect and to see data from queues or push messages on a queue, there's authentication. So there's also the authentication server involved. So let's see if we can find more information on that, how the interaction is between these two services. So most of the times you have the producer and consumer application, you write them yourself. You focus on observability for these applications. But the JMS server and also authentication server is most of the times it's commercial products. And we have logging of these applications. So the auth server, I requested the team as well, can you provide me the log files as well? And then we can see what we can find there. So again, a Logcli query. So this is the access log file for the auth server. And then give me all information from that particular machine. And then you can see a lot of connections are coming in. So at least we see the connections coming from the JMS server to the auth server. One thing you have to know more is we have the JMS server that's creating connections, but also having a persistent connection. So the JMS server has a persistent connection. It's using the LDAP protocol. It's having a persistent connection to the auth server, and it's doing query. Okay, but a new user is coming in. Does the user exist, and what is the DN of that user? And then for that user is then authenticated over a new connection. So then a bind is done, and with a bind, that's the actual authentication. Is the username and password, is that valid? And then after that, the persistent connection is again used to query. Okay, in which groups is this user available, and even the group is that also participating in other groups. So we are able to find all the connections, or at least to connect, but then we need to know what is happening on these connections. So one of the advantages here is you see a connection ID. So that gives some indication that there is more about this connection. So I did a query on 2 of the connections, and what you then see is you have a connection, and you see a connect coming in and a bind. So we see that the authentication is done for this user, and here also again a connect and a bind. So we need to find out all the connection IDs. So what we can do, again a LogQL query, you have the from the user, so and you can extract the connection ID and then print the connection IDs. And if you do that, then you have a list of connection IDs. I'm a bit lazy. I don't want to copy paste all these. Here you can see 87 one by one copying them. So what you can do, you can download the file, so then you at least have it in a text file, and then you can do things in your text editor. But there are more things you can do. There's also Logcli. That's the command line util, also from the Loki team, which you can use to query and send LogQL queries from the command line to Loki. And if it's on your command line, on your shell, then you can use all other tools you have on your shell as well. And other things you can do scripting, you can do store it in variables, you can do sub actions with it, combining it in one command. So what I did, I downloaded the Logcli. I created some environment variables, and one of them which you can easily use is the Loki address. So either you can connect to the Loki server itself, or you can do proxy through Grafana. I also created 2 other environment variables for the from and to, then you don't have to mention the time ranges each time. And I created a function for myself that makes it a bit easier to do this query. So then I can use this as a command line action, LogQL. And I will switch to the command line. And this is the same LogQL query I showed you before about from this IP address, get the connection ID and print only the connection ID. So when you run it, you have the connection IDs on your command line. So now you can do anything what you already can do with your command line. So one of the things you can do is, for example, count the number of lines. So it's probably a bit hard to read, but here again 87. So we have the same list. But you can all do things like sort, and then you get it sorted. But you can do anything with that now. So then you can use also other tooling, and now I have them just all on one line. So now you can copy paste it and use that again in the browser. So let's go to the next step. So I copy pasted it, and now I have all the connection IDs available in the browser. And one other thing you can do is, so this is one log query, and then you can add another one as well for the JMS. So then you have the log files from the access log and the JMS in one file in one shot. And let's see what we can find then. So again, we see all the disconnects. We have to scroll a bit. And now, one of the first things we see is, here is the user lookup. So the first action done from the JMS server, a check is done. Does this user exist? Now you see also here a connect and a bind, and you see searches done. So the group lookup, in which group is the user, and also you see nested group lookups. So you see a lot of actions now coming from the JMS server to the old server. What if I can visualize this? And I hope you can read this part, but I will see if I can highlight it more. What you can see here, so this is again the same information from the logs, and at the start you see a timestamp. When you have logging, most of the times you have a timestamp in your logging, but at that moment the action is done. So that means that's the end of that action. But also in the information, you have in this case for the LDAP protocol, you have the E-time, which is the elapsed time. So you know the end of the action and you know the elapsed time, so you can calculate the start of it. And then you can create you can create a block of it, and you can repeat it. So then you see the same information again. And if you do that step by step, you see that you already get some more information. Then we have the old module that also has the end timestamp, but there is no information about when did it start. But what we know is you have the username. Here you have the username, but at first, in the first moment, there was also the lookup for that same username. So you know at that moment already that action started for the user. So actually, you know, this is the end moment for the old module, but it started already at the moment the first lookup was done for that user on the old server. And then you have the information about the connection. There you see the offset. That's the moment the client created the connection. And if you combine that, then you have some information also about the connection. And if you then have a look at what's here below, this looks like a Gantt chart, or what you also probably can do is create a trace. So for the spans, you need an end time. So that is the time stamp in the logging. You need a start, and then you have the E-time or the offset time, and you have the correlation, and that's a bit of the tricky part. So how to do the correlation between these items. So what I did is I created Java code. I pressed the download button in the UI to get the merged file. I parsed the file. I created custom spans. I did the correlation in Java code, and I created a trace file from it. And then you can use the upload JSON file option in the browser. And then let's see how that looks like. So here you can use the import trace function. You can choose the file and then upload it. And this is how it looks like. So here you see the reconnects and the connects coming, and here you see also quite large times. And also here at the top, you see also a big green part, and that references to the long waiting time, so the long offset time for the connections. And you see here a lot of these connections are coming in and having to wait for a long moment before the actual connection was established. We zoom in a bit more. So I only took a part of the file. So you can see here the connections coming in. And if we then open the first one, here you see the old module being active. So actually the whole time of where the first connection was coming in, it took the time for the authentication. And while this authentication was active, more connections came in, but they didn't do anything. So if you open the next one, you see the old module for this one started working after the other one was finished. So if you then open this one, again, this one started working when the other one was finished. So if you just focus on the old module part, then you see if you just take these, you see also here in the part above you see the line, but also if you have here, you see all these actions are done sequential. So one connection has to wait for the authentication of another one before it can continue. And that feels like a bottleneck. And if you zoom in more, I created an aggregate for convenience reasons, but if you then have a look here, on the alt server, you see that first search action, so the lookup of the user, you see the bind action, then you see a lot of search actions. So this is the group search and the nested group searches. So with this, you can also see the bind action is giving problems. And then I'm always so I see this information in one way. Can I also visualize it in other ways, or can I find the same information? So the bind information is in the log files. So again, a LogQL query with an average over time for the bind action. Take out the bind, the duration of it, and then you see at these moments on the alt server the bind times go up, and that is causing the problems where the authentication are taking long. So in summary, we started with a problem where the producer and consumer were not able to create the connections to the JMS servers. They had to wait long, and some of these applications were impatient and were not waiting till the connection to be created and tried over and over again. So that was also creating more connections. And then they gave up because they didn't get a connection. So a number of these applications had to restart. By digging into the log files of the JMS server and also the authentication server, we were able to find a number of problems. So the performance of the alt server was not correct. So that has to be improved. But also the JMS server had to fix a number of things, making sure that you can do the authentication in parallel rather than sequential. And also one of the things we found is that the nested group part was also not required. So that also saves a lot of search actions done from the JMS server to the alt server. Conclusion: dig deeper. Is it really the network, or do you have other problems? Also the observability data is key. So sometimes you only have the logging, but there is more. If you have more information, use it and explore it and try to find the problems. And also visualization helps. And that's what I showed you. Just by going through the log files, you will not always see the actual problem. And by visualizing it, then you can see what the actual problem was. What also helped in this case is not having just one trace in the overview, but actually having all the traces of all the actions for the users being in one big trace file. And also be creative. If the tools don't support it or don't support it yet, then you probably have to do some more things yourself, and then still you can reuse the same tools. And one other thing I realized after the sessions of yesterday is what I will do. I will replace the Promtail and OpenValue corrector with Alloy and give it a try. And I will create also a new blog post about it. And also, I think also with the Loki tree options, also with the pattern recognition, and also with the explore logs feature, I think, and I will kind of revisit the same thing to see if also finding the problem lines and for example the log lines with the offset, if you get these out of it more easy with this. I'm really curious how that looks like if we use the explore log feature with that. That's it. Time for questions, if time permits.